All right. So my plan today, since we got 1 day extra, was to talk about C++, just kind of show you another object-oriented language, one that's older than Java, but similar to C, which you know a lot about. So anything you want to talk about or ask about before we get into that? Anything about the exam or what we've been doing or the universe?
6 programming questions and a few multiple choice.
6 programming questions, 15 multiple choice.
Can you explain deadlock and live lock?
Oh, deadlock and live lock?
Yeah.
Sure. The main thing to know about those is basically they deal with 2 or more processes that are fighting for resources, right? You and I both want a pencil and a paper so we can do something. You've got the pencil, I've got the piece of paper, right? And I can't continue until I get the pencil and do what I need to do, and you can't continue until you get the paper and do what you have to do. And if I just say I'm just going to wait until I get the pencil, I'm never going to make any progress, okay? And if you're just waiting for the paper, right, before you do anything else, you're not going to make any progress, so we're deadlocked, okay? Live lock might be I wait 5 minutes and the pencil's not available, and I say, okay, I'm going to return my paper to the middle of the supply cabinet. I'm going to come back in 10 minutes and try again. And you put your pencil back and you say, I'm going to come back in 10 minutes and try again. So we come back in 10 minutes, I take the paper, you take the pencil, and now I'm waiting for the pencil again and you're waiting for the paper again, right? And so our state is changing, but we're not getting out of this fundamental lock situation. So that's usually what live lock is.
So live lock is about infinitely looping on a problem.
But still not making any progress.
Change states.
Yeah, you're still changing state, but you're locked. And I don't think the distinction for what we've done is critical there. The main thing to know is that there's cases where you have multiple processes competing for resources, and if you don't do things right, you may find a situation where neither process can finish. All right, so that's a deadlock or a live lock.
So it's a second line,
A SIGIN?
a second line, second line, second line. So in the practice, then the topic is
Let's see.
second line. Going down, center line. Yes,
Synchronized.
Synchronized.
Okay. Yeah, so synchronizing is a way to avoid some of these situations. So for example, we can say, so let's continue the example. You need a pencil and paper, I need a pencil and paper, right? And there's a supply room that has the pencil and the paper in it. Okay, so what we could do is we could have a flag. And whoever is going to go into the supply room and get the pencil and paper, they have to wave that flag up in the air, okay? So I approach the supply cabinet, I get the flag, I put it up in the air and say, I'm using the supply room. I get the paper, right? If at that point you come along and you want the pencil, you're not going to start that section of code because you can't get that flag, okay? So that flag, that's what the synchronized keyword does. We say synchronize and we name an object, right, which is used as a flag. And anybody who wants to run that section of code has to be the first one to start that block of code. If somebody else is running this and you come in and you try to run it, you're going to wait until that code gets executed. And I did make an example of that. So I don't know if this is going to help or hurt, but so here's a thread class, okay, and flag is just a string. It's an object that I'm going to use as a flag. So I'm going to construct my thread class. I'm going to pass it that string, and it's going to save it in this class variable called flag. And then the run method of this basically says do a forever loop. Try to get access to that flag object, right? So synchronize on the flag, print out a message saying the thread is here, and then go to sleep for a second. Okay, that's all that this does. Print out a message, sleep for a second, print out a message, sleep for a second. But this section of code where it prints the message is in this synchronized block. Okay. So let's take this keyword out of here. And let's just say forever loop, print out the thread is here, sleep a second. Print out the thread is here, sleep a second. Okay. My main program has a flag, which I just set to haha, has a new thread T. My main method, I'm just going to run this go method. And go is going to do the following. It's going to construct a new object of type T. Okay, that's a new thread. It's going to pass that flag to it. It's going to say start. So this starts that thread that starts the thread running. Every second it should print a message. And in here, I'm going to say sleep 5 seconds, ask the user to hit the enter key, and then once they hit the enter, come out here and say thank you. Okay, so the main thread prints something every second. This thread waits 5 seconds and asks me to hit enter. And once I hit enter, it'll say thank you, sleep 5 seconds, ask me to hit enter, and so on. So if I just run this, right, so the thread is there, it's running, every second it prints out a message. And while it's doing that, my main thread says hit enter to continue. And the thread's continuing to run, right, but as soon as I hit enter, the main thread says thank you, it sleeps for 5 seconds, and then it'll come back and say hit enter to continue. Okay, so that's just two threads both doing their own thing, which means that potentially they could get into this kind of deadlock situation. Okay, so we use the synchronized keyword. And we say before this thread can print out thread is here, it's got to get access to that synchronized flag. Okay. The main code, when it asks me to hit enter, that thing that waits for has next line to come back true, that's also in a synchronized block. So if synchronize is working correctly, this loop cannot run at the same time that this print message is happening. And if that loop is running, this print message should not happen, right? If I'm in this while loop in my main program waiting for the user to hit enter, after a second when the thread comes back up here and says synchronized flag, it's gonna get stalled. It's gonna be forced to wait until that other thread releases that flag. So here if you run this, the thread is there, 5 seconds later, the main thread says hit enter to continue, and that other thread has stopped now, right? It's paused, it's about to say synchronized flag, print out thread is here, but I can't get into that section of code because I've got the flag, right? Now once I hit enter, I leave that synchronized block in main, I release the flag, now the thread can get the flag and it can continue. So it's really forcing so you could use that for PA5, you could use it anywhere, but you can use it in particular if you've got a possible deadlock situation. So if you need multiple resources and this other thread needs multiple resources, before you start allocating any resources, grab a synchronized flag, right? If somebody else has already started running their code that uses those resources, you won't be able to start your code. If nobody else has started, you'll start, and nobody else can come along and start running their code at the same time. So it guarantees that I can do my thing and not be disturbed by somebody else's, some other thread's actions. All right, other questions? Yeah.
It's on Monday, right?
It's on Monday, 10 o'clock or 2 o'clock. All right, so let's talk about a little C++. C++ looks a lot like C. It's C with objects added on top. You can take a regular C program and pretty much run it as if it was a C++ program, right? It's mostly a superset. So to compile C++ for the new compiler, it's just G++ instead of GCC. And the usual switch is G++ -O, etc., etc. So here's test1.c. This is hello world. So we include IO stream, that's like standard IO.h. We have our main program. And then there's one statement here, standard : C out. Okay, this is a synonym basically for standard out. And this double less than sign is basically like an arrow. It's saying take this stuff and send it into standard out. And that's one way to print things in C++. You just use a double arrow and copy it over to standard out. So G++ -O, run test1, there's your hello world. All right, we use C out and C in a lot, and writing std : C out is a pain, so we can use the statement using namespace. And this is kind of what an import statement does in Java. When you say import java.util.star, it means if I use a class and you don't know what that class is, see if it's described in java.util. Okay, so it's kind of like wildcarding almost. It's saying if you don't know what C out is, which it's not going to know, check to see if it's std : C out. And so it saves us from writing the class in front of C out all the time. So this will also work. This will take this string cool and send that to standard out. All right, so that's a little easier to use. We can string multiple things together in a single line. So having multiple things all directed over basically says send this to standard out, and then send this, and then this, and then this. And ENDL, that's another built-in, that's basically our new line, end line. So that's \n. If you're tired of writing \n, which you've been doing for years, right, you can just use ENDL. So this will basically output cool, a new line, haha, and a new line. So it's 2 lines of output. All right, so not too surprising there. All right, so next thing about C++, it has strings. So we don't have arrays of characters with null terminators and things like that. We have a type called a string. And we include angle bracket string. And now we can say string x comma y. And it's just like int or float or double. X and y are now strings, collections of characters. And we can give a value by saying, for example, x equals hello. And then if we say y equals x, that'll set y equal to hello. And then we can set x equal to by. So now x is by, y is hello, and this will output x to standard out with a new line at the end. And this will output y.
So the double arrow means that kind of like the addition sign in the Java, right?
A little bit. It's so this one right here is kind of acting like the plus sign, yeah.
But when I was seeing the document, it said it's kind of a stream direction of the.
Yeah, so it's really saying take this and send it to, in this case, an output stream.
Yeah, so
And when we do the arrow the other way, it's saying take an input stream and copy it to a variable. We'll do that next. So it's just particular syntax for C++, but it's a convenience. It's a fair bit easier than doing printf with the %ds and all of that, and it's a whole lot easier on input.
Yeah.
All right, so this is another peculiar thing we can do. So x equals parentheses y equals 12, comma z equals 3, comma y plus 1. This is a shorthand way of doing multiple things in one statement. So x equals whatever the value of the right-hand side is, right, which is something in parentheses. So when you have this thing in parentheses, it basically does each of the things in there. So this will set y equal to 12, and then it'll set z equal to 3, and then it'll take the current value of y, which is 12, and add 1, that's 13, and that's the last thing in the parentheses. That's the value of that right-hand side. So after it sets y to 12 and z to 3, it will set x equal to 13. Okay? I think that makes sense to some people. I don't use this feature a lot, but it's another way to sort of simplify your code. All right, so x is 13, y is 12, z is 3. And someone in the earlier class asked how to print out a quotation mark, so you just use a back quote to print a quotation mark. And then the way I doctored this up, if you just said x equals parentheses, y equals 12, z equals 3, the last piece of that statement is z equals 3, so that technically has a value of 3, and so this sets x equal to 3. Right, it's kind of like saying x equals z equals 3. So x is 3, y is 12. All right, so on the input side, we can say cin greater name of a variable. And that says read from standard in and assign the value you read to that variable. So in this case, x and y are integers, temp is a string. And when we say cin greater x, it'll read whatever we type as an integer, assign that to x. Same with y. When we say cin greater than temp, it will take what we read and treat it as a string and assign that to temp. So we're prompting with cout, we're saying enter x, read standard in, save it as x, and then enter a string, and then enter y. And we'll just print out those values. And I gave x and y initial values just to show that it's actually doing output. So x might be 33, and a string might be hello, and y might be 45.
How does it handle the improper input?
What's improper input? Oh, like if I don't give it a number?
Yeah.
All right, so it breaks. A little like what scanf does. Right, so scanf, if you try to scan an integer and a string and an integer, and the first thing's not an integer, it gives up right there. Right, and then your other values remain unchanged, and x got converted to a 0. So it's very scanf-ish. Right, now for my string, I put in 3 values. The string is just equal to this, and y is equal to 0. And that's also scanf-ish, right? When you scanf with a %s, it only picks up to the first white space. And so this was absorbing this as the response to input a string, and then it absorbed is as a response to input y. So when it said input x, I could have said 17, haha, and 89 on that one line, and eventually when it does those other inputs, first one went to x, next to temp, next to y. So I think scanf and all that implies. And we can also do multiple inputs on one line. Cin goes into y, goes into x. Basically just saying read cin into x and then read cin into y. So it just does it in one line instead of multiple ones. And again, if you only put in one value, it'll sit there and it'll wait for you to put in the next value. All right, well, that's fine for reading from standard in, but we can also take a string that's already been formed and we can say interpret this as an integer. And so this string stream function, basically you can think of it as taking a string and turning it into input from standard in, right? So if I said cin greater I, it would read from standard in, treat it as an integer, convert it to an integer, and store it in I. Instead, I'm saying string stream buffer, which says take the characters in buffer and act as if that had been typed on standard in and save that as the variable I. So here I can read from standard in to buffer, and buffer is a string. It's declared as a string, but it'll still convert it into an integer. And we can prove that by doing integer-y stuff. On I. So haha, this is fun, and we can type 25, and I plus 2 is equal to 27. So it really is an int. So string stream is kind of like an scanf. Not a drop-in replacement, basically that idea. Right, let's just build a string first and then convert that into an integer in this case. All right, we can also iterate across the characters in a string. So here I'm going to read a string and save it in buffer, and then we can say for character C : buffer. And this is peculiar syntax for C++. We don't do this in C. But it basically says C is a character, and I want to iterate over each element in buffer, each character, set C equal to that, and then do whatever's in the body of the loop. In this case, just print out the value of C. Yeah, basically. So let's just print out character I is and then show what the actual character is and increment I. Say hello, and there's your loop. And I also did a string name.length to show the length of the string at the end here. Right, so this is object oriented, so strings come with methods, and length is the same method we use in Java. It gives you the length of the string. So that works too. And I put a little note here. This is not totally standard C++, but if you use standard equals C++ 11, then it lets you do this. All these compilers have different versions, right? If you look at the man page for GCC, for example, there's so many different versions of this. And they support different features, and they're built for all kinds of different architectures, and somebody wrote all this. I don't think anybody's ever read all of it, but I don't know, maybe they have. But if you're using GCC on a particular machine and you want to know about a particular feature, right, you can search for this and find it. It's a manual page, which is up to 16,000 lines. I don't actually know how long this goes. There we go, 18,000 lines.
What is the newest of
What is what?
Newest version.
I don't know.
C11.
Let me see what GCC is. So GCC is 7.4.0. What is G++? Yeah, but I don't think that's the whole answer. 'Cause that's my version of Ubuntu.
C language is
I don't know. It'd be an interesting thing to check.
I don't think C language will change a lot,
Right.
as it's quite basic language. But C++ may differ due to the grammar.
Calist. So C++ 98, C++ 98, C++ 03, and then 11 was 2011. There's a C++ 14 and a 17.
Oh, sorry, that's C20.
Oh, and C++ 20. Expected to follow 17. So it looks like every 3 years or so they come out with a new version. Because that's what standards are about. It's like updating them and changing them. All right, so this also supports something like generics in Java. So we can define a template, right? Keyword template. And in angle brackets, I say type name, and I have basically a variable, which I'm calling var type. We could call it anything we wanted. But the idea is I want to write some code that works with more than just integers or doubles. I want to write a code called sub, but it can support different types of arguments, x and y. But whatever type of argument it has, I want it to return that same type of variable. So I have a parameter here called var type. Right, and that's just a name. It could be called, you know, Kermit or something. And so instead of saying integer or double, I just say var type x, var type y, and it returns a var type. And when I call this function sub, depending on what type of variable x is, right? If x is an int, then var type is an int, so it expects y to be an int and it expects to return an int. And if this is a double, then y will be a double and it'll return a double. And it's basically what generics do for us in Java, right? We can make a linked list class and it can handle strings or rectangles or doubles or fractions or anything else. And in Java generics, right, when we construct our object, we actually tell it what type of parameter we want, and here it's interpreting it. So I've got this subtract routine called sub that just takes the two arguments and subtracts them. And I can call it with two integers, I can call it with two real numbers, I can call it with two characters. And in each case, it does whatever is appropriate. Right, so 5 minus 23 is minus 18. 10.23 minus 1.1 is 9.13, and little c minus big A is single quotation mark. Right, so when you subtract characters, it subtracts ASCII codes. And that's 99 minus 65 is 34, and that's the ASCII code for a quote. So it's basically a generic facility that you don't have to write a separate version of your functions for every possible type. All right, so classes, right? It's object oriented, so let's talk about classes that we can construct. So very similar idea to how we do things in Java, different syntax. So class is the keyword, circle's the name of the class I'm creating, curly bracket. Okay, we can say public colon or private colon, and that applies to everything that comes after that. So public colon right now is making everything public. If I had something I wanted to be private, I could say private colon, and then the following things would be private. And you can switch back and forth like that. So all of this is public. So circle has a radius and it has an X and a Y, which is where the origin of the circle is going to be. And I have a set radius method. Okay, and there's our favorite keyword, this. So we're using arrows because it's C-ish. So this arrow radius equals radius sets the class variable radius equal to the argument. Set location, we pass it two doubles, it saves those as X and Y. I'm going to fix my area method because my area method is weird. Because it should be pi r squared, not 2 pi r. So there's the area of the circle. And distance just tells me, let me add some comments. So how far is the origin from 0, 0? So that's what my distance function does. And so there's my whole class. And then to use this, so here's my main code, I just say circle C. And that constructs a circle named C, and there's no new keyword required. And then I can call set radius 5, and I can set the location of the center to 2, 3. And then I can say, let's print out the area. And let's print out the distance from the origin to the center, and let's print out the radius.
I saw a lot of tutorial about C++ that they divided the class file into a header file and actual.
Yeah, I'll show you an example of that. We can split this up into a description of basically function prototypes and then actually write the code outside that. Or you can do it all in the same section of code, which is what we're doing here. But I'll show you how to split it up in a minute. So this is a circle object.
Basically, but we don't need the objects.
You don't need to what?
We don't need the objects.
You don't need to say new.
Yeah.
Right. Right, so there's area, distance from the center, and radius. And yeah, when we declare a circle, we just say circle C, rectangle R, right? And we don't have to say new.
What about constructors, do they work the same way?
Constructors basically work the same. So here I've got a couple of constructors. I've got a constructor, right? The class name is circle, so the constructor is named circle. And here's a constructor that takes a radius and an X and a Y, right? And it actually uses the set radius and set location methods. And then there's a constructor after that which just takes a radius and sets the origin to be this 0, 0. And there's the same set radius and set location code as before. And I'll fix my area code here.
Is there a reason why classes aren't capitalized?
I don't know if that's actually a convention or not. It's possible that they are, and I just didn't do that because my actual experience with C++ is fairly limited. So there may be conventions. So yeah, here we construct circle C by specifying all 3 parameters, and then circle D we just pass a 7, which is a radius, and so it should be situated at the origin. So we'll print out everything for D and for C. Alright, so that first one had a distance of 0 from the origin. So same thing we've been doing with multiple constructors in Java. All right, so here's an example where we define the class, but the area method I'm not actually describing inside this section of code. I'm doing a function prototype. So what does it return? What's its name? What type of arguments does it want? and then I just have a semicolon instead of curly bracket, code, close bracket. So it's a plain old prototype. And the definition of area is not contained in this part of the code. So our class description goes down to here, right? And all I've done is given it a blueprint for what area should look like. But then outside, I can define my area method. So here I'm saying double circle colon colon area. So circle is the class, area is the function, and then there's the code for it, which is still not the correct.
Originally a circumference function, wasn't it?
Yeah. And I don't know if I changed the name or if I just messed up. All right, so this is where you can have one section that basically defines the prototypes, and then you can write the code elsewhere. And then the use of that's exactly the same.
Can you have a header file with all the function prototypes like C?
You should be able to. And I in fall, I had one of my goals for tenure was to learn C++. So I ported a big Java project that I'd been doing for a few years over to C++, and that got me a little more into some of these details of having your header file and or your prototypes and then your actual definitions and so on. So for me, C++ makes more sense the more I use it, but when I first tried to learn it, it really didn't click for me. And maybe that was because I hadn't done Java yet. Maybe it's because it was my first object-oriented language. But when I started looking at Java, to me, it just felt very natural. And it could be because it was a second attempt, right?
I don't know, I'm the same as you. I started with Java, but still C++ was a nightmare.
Okay. On the other hand, C++ is going to be faster, right? Because it's compiling down to the hardware level. Whereas Java's got the layer in between with the JVM.
Yeah, I saw a lot of microcontrollers using C and C++.
Yeah, and Arduino is actually, it's mostly C++. If you use Arduino, any of the libraries, it's in the sense that it's got objects on it. It's not usually this kind of stuff, but it's basically an object-oriented C. And one of the game engines, is it Unity, uses C++? It's either Unity or Real. C Sharp,
Yeah,
that's right.
C# is a pure object.
Yeah. So you can have default constructors too, right? So there's a constructor with no arguments, and so I set the radius to 1, origin to 0. And so if I just say circle C, I've got a circle, and it's done whatever I did in my default constructor. I'll fix this one last time. There we go.
And you can call the non-default constructors to create the same circle C.
Mm-hmm. Right, so if do I have one in here? Yeah, I do. So if I said circle C, parentheses, something, 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 right, then it would call this constructor that takes 3 arguments. So most of these ideas we've been working with from Java, right, really carry over. Here's one that doesn't. So I should redo this with fractions, but I did this in a rush. So, when you make your fraction class in PA1, you make an add method so that you can take one fraction and say add another fraction, you get back a fraction, which is the sum. Okay, so imagine that we're doing this here, but instead of fractions, we're just using these things called mynums, which happen to look exactly like integers. But that's just because I'm lazy. So there's a class named mynum, right, and it has one value stored inside, which is an integer. Yeah?
The class doesn't have every word capitalized.
No, it doesn't. And like I say, I don't know if there's a convention that says classes in C++ should be capitalized or not. But Let's see. Let's just stick our head in the lion's mouth. Is there a common capitalization convention in C++?
It's wrong.
Yeah, so of course there's the stuff we have to work through first. So camel case, had to face this decision. So I'm going to guess that the answer is no. Let's first agree that all uppercase is an eyesore and should be minimized. Well, okay. Macros only because macros are equally ugly, not to say evil.
Very creative.
Yeah. So,
Back to the,
so unless someone tells you what to do what feels good. The general rule. All right, so we've got a mynum, right? So I slipped into camel case for my classes. And it's got one value, which is an integer. So I can construct a mynum, I pass it an integer, and it just remembers that value. And I've got one function in here, which is just called op. And what op seems to do is multiply two of mynums together. So it'll take the value of this mynum, right, and it'll multiply by the value of the argument. And the result of that is used to construct a new mynum. So I create a result, and then I return that as the value of op. So if I construct a mynum A, which is going to be equal to 10, and a B, which is equal to 20, and then I say A dot op B dot value, that should be 200, right? 10 times 20, and this should just output 10 times 20.
earlier you did this arrow radius. Is that the reason mine is on?
Earlier I did what?
Earlier in a constructor.
Oh, this arrow radius?
Arrow radius.
That was just because I had the same name of the argument as I had for the class variable. So that was, and you can avoid that by using different names. I could have passed R and then said radius equals R. So that's the usual this business. Right, so if I run this, it tells me that, A op B is equal to 200. Okay, which is nothing to write home about. But here's an almost exactly identical version of that, except instead of calling this function op, I called it operator plus. Okay, it's exactly the same. It takes a y, it multiplies its value by my value, constructs a new result with that, a new mynum with that, and then returns it. But now, if I can construct an a and a b to be equal to 10 and 20 and y, I can say y equals a plus b, and it's not doing addition. It's calling this code, which in this case is multiplying my two numbers together. So for mynums, the plus operator is now multiplication. Okay, this is called operator overloading. So I'll say y equals a plus b. And 10 plus 20 is 200, because I've changed what a plus sign does. And that's kind of cool. So if these were actual fractions, right, I could take my add method, instead of calling it add, I could call it operator plus, and I could take my multiply method and call it operator star, and then I could actually have two fractions and say a plus b, and it would call my addition code, or a slash b, and it would call my division code. And so not only can you define your own types of variables, which is what classes basically give you, but I can redefine what these basic primitive operations do, which is potentially nicer than, a plus b plus c being a dot add parentheses b dot add parentheses c close paren, right? So I can just say a plus b c. So that's operator overloading, and that's one of the things that C++ does that Java doesn't. And if you Google is operator overloading good, you'll find, you know, lots more opinions.
Locked.
It's considered by many to be a bad thing.
Only by the ignorant.
Yeah. So okay, so that's my brief intro to C++. Just as another object-oriented language. And once you've learned one, right, Java, picking up another object-oriented language, not a real big deal. It's mainly this shift in mental gears to, you know, instead of calling some function parentheses list of variables, if that function comes from a class, you say object name dot function name, and then you pass variables. And it's almost second nature. If you've ever played with Arduinos, right, this is what you do with Arduinos. Because everything you do in there is an object. But it doesn't beat you over the head with, you know, you're constructing an object and you're instantiating and all this. It's just, it feels pretty natural. And so Python, C++, Java, lots of differences, but nothing that's like the difference from, say, C to Java, which is much more significant. So WSU does a fair amount of Python these days. I don't think they do a lot of C++. They still do C. So you'll bump into all these different variants.
You don't do C++?
UW, I don't know. I know they do Java, because their 143 is Java, I believe. All right, so I think you're all in really good shape as far as Java and programming in general. And it's definitely been fun having all of you in class, especially for like 3 quarters in a row, plus maybe 250, 270 last year. Congratulations on getting through all this, and I will see you Monday for the final.
We only have one section?
Sorry?
We only have one section on Monday.
There's a final at 10 and there's a final at 2.
Oh, that's
Because there's 2 sections of this class, 10 o'clock and 2 o'clock.
It doesn't matter which one you show up to.
Doesn't matter which one you show up to. If more than 35 people try to crowd in here, we'll have a problem. But
because we may have a physics exam on Monday at 4 p.m.
yeah, they can't conflict. They can't conflict because of the way the schedules are set up, unless the classes themselves conflict. So, but if you've got a 4 p.m. exam and you don't want to go back to back, come in and take the morning one. But then you got to get up early. All right, cool. Have a good weekend. I will see you next week.